Hey everyone, this is Andrew Foy from Radford University. Today I'm going to talk about georeferencing and spatial adjustment, which is another kind of brief lecture for the Intro to GIS course here at Radford. So for most of the semester we've been dealing with data that has a spatial reference, so that means it's got likely a projection and a coordinate system that we're aware of. It's that one has been picked for some reason, maybe because we want to retain properties of distance or shape or area or direction. And when we conduct a correct spatial analysis, as you guys should know, we always make sure to match projections. So if we have a layer that's in UTM and a layer that's in state plane, we've got to pick to project one or the other so that everything in our table of contents is in the same coordinate system and also in the same projection. Now, one of the things that people make a mistake doing is trusting in ArcGIS to auto-transform on the fly. And so sometimes you get that error message that says, hey, coordinate systems or datums don't match. And oftentimes you probably just don't pay attention to that. It's okay visually, but if we're doing a spatial analysis, which when we get into more advanced classes you will, it's really important that everything is the same. And so one of the problems that we also encounter is that maybe we get data from a person and there is no spatial reference with it, or maybe we've got data we've collected ourselves in some sort of analog form, like on a paper map, or maybe we've taken some sort of aerial photography, and to use that in a GIS, we really need to give that data a spatial reference. So just for an example, we have a topo map here, and you might think, well, why in the world do people still use and collect geographic or environmental data on paper maps? But as it turns out, these things are really useful in the field, right? For one, the batteries for this can never die. But also when we're out in the field, there may be conditions or reasons why we enter information on a paper map. Maybe it's just easier and more efficient. Or for example, when I worked out in Dinosaur, Colorado, we were trying to map out peregrine falcon nests. And these nests were on the edges of cliffs that we could often not climb down to. So if you can't climb down the cliff or you can't even access that spot, how are you going to use a GPS? And so what you need to first do is find your location on the topo map and then use a compass and basically plot the location of those nests on this map using basic orienteering techniques. And so at the end of the day, maybe I want to take those plotted coordinates on the topo map and get them into a GIS. So how do I do that? Well, georeferencing is one of the techniques that we would use, or also spatial adjustment. We'll talk about the difference there. But basically, if you follow this workflow, I would scan this paper map, turn it into a picture, and then I would load it into any GIS package that I have to go through the georeferencing or spatial adjustment process, which is basically giving our data a spatial reference. And we do this by referencing it to something that already has a spatial reference. So we have unknown coordinates, and we match them to known coordinates, right? And oftentimes we do this, or one of the things you might look for if you're on a topo map is topo maps have tick marks on them that contain coordinates for both the X and the Y axis, right? So you can basically determine the northing and the easting, right, from these tick marks. And if you can identify the tick marks on a topo map, and then you're using a coordinate system where you can type in the coordinates and match them up, we can basically move the map into a grid that has a spatial reference, thereby giving it the information we need to leverage in a GIS. So we can look for places where we have reference markers that give us information about that coordinate, or if we're not dealing with maybe a topo map, but something that we've hand drawn in the field, or maybe we're using something as simple as a road map, we want to look for spots that are really easy to identify. So oftentimes the intersection of a road is something that we can use to do georeferencing operations. Or maybe we pick the corner of a building or some sort of easily, identifiable peak where we have very distinct features. And basically, to do a georeferencing or spatial adjustment, you need a minimum of 3 of these so that we can fit one data set into the grid of another. So let's now look at a few PowerPoint slides. If you want to follow along, these slides are in the lectures folder in D2L. Okay. So as I mentioned before, we're talking about georeferencing and spatial adjustments, and there is a little bit of a distinction that I want to make between the two. So georeferencing basically uses map coordinates to assign spatial locations to a feature, and this is typically done with raster data. So imagine we have some sort of aerial photograph or something else that is in raster format, so like a picture, and it has no coordinate system or projection. Maybe we took it ourselves, and we want to basically give that a spatial reference by referencing it to data that has known coordinates or spatial reference. Spatial adjustments are basically the same process, but this is done typically with vector data, and sometimes we do spatial adjustments because there is no coordinate system, but other times we do it because for some reason the map has been distorted or rotated. Typically this is done erroneously or by accident, but we need to fix the data. We might go in and need to fix the geometry of it. So here's an example of georeferencing where maybe we have some picture data and we want to match that to something with a spatial reference. And so here we might be able to use the corners that are from the corners of the counties to match up to corners on something else that we can see. So again, matching data information with no spatial reference to something with a spatial reference. There are many different tools to allow us to do this. So for example, in ArcGIS, you can turn on the georeferencing toolbar. You can also turn on the spatial adjustment toolbar. And in QGIS, there's a plugin that allows us to do this. One of the things I just want you to always make sure that you're doing is using the correct layer as your input. So as we begin to have more and more layers, sometimes by default we georeference something that already has a reference. So always make sure you're working on the correct layer. Okay, so here's an example of when you might do a spatial adjustment. You can see this is vector data, and it is the blue stuff is the original, and the red is the newly collected information. And for some reason, it's been distorted. And so what we might do is go in here and match this corner to that corner, this corner to this corner, that corner to this one, and we would go around trying to match as many locations as we could. And what that would do is it would adjust the data and move it to fit that exact same footprint. So there are many uses for that. Now, when we talk about the points that we pick to do the registration, these are referred to as either registration points or anchor points, right? And again, remember that you want to pick easily identifiable points on the map, and then also on the map that you're matching to. And it's pretty easy to see if you do this wrong, because you will have a lot of distortion in the map, or if you look at your error or the residuals that are often reported to you in a table or visually, those will be quite large. And so always think about the units you're working with. And if you have something like 780 and you're in UTM in meters, a spatial adjustment with residuals of 780 meters is not very good. Now, in industry, sometimes you'll hear people refer to these processes as rubber sheeting. And that's just kind of, even though that's a technical term, people use it very generically. And in fact, there are many different methods and algorithms that people use to fit geographic data to known coordinates. You'll also hear the word rectify sometimes used for georeferencing operations. Again, this allows us to take raster data and fit it in or fit with data that already has a coordinate system. So on the left here, you can see that this is a map of Radford University. And when I was out in the field, I was doing a laser scan using terrestrial LiDAR of the whole campus to make a 3D model. And I took field notes so that I could map out the locations of my scanner when I did the scans, but also my target locations, because I wanted to be as efficient in scanning as possible. And then later on, I wanted to put this into a GIS. So I basically scanned this map. And then because I have building footprints and roads of the university, I was able to georeference this map to that one by picking road intersections and building corners. So, anytime you're using a map out in the field, it's always good to have one with a known scale and also a known coordinate system. So topo maps are always really helpful. If you're going to be doing field mapping, think about steps you can take to make the georeferencing process as easy as possible. Often picking man-made or linear features for registration points is the best. So really think about what you choose to match up and really pay attention to your error vectors while you're doing georeferencing. Sometimes 1 or 2 points can really throw the whole thing off, or if you make a mistake like adding 1,000 instead of subtracting 1,000 for values near tick marks, you could very easily have a goofy looking map. So basically what I want you guys to do for this lesson assignment is to write between about a half-page document explaining what georeferencing is and how you think you could use field mapping and georeferencing in your discipline. So if you're a biologist, is there an example of how you might use this to create GIS data? If you're a geologist, how could this be helpful? Or even if you're a criminal justice major, try to think of a reason why you might have to georeference information. And so give me a brief explanation on this process. What is georeferencing and spatial adjustment? And then provide me with an example of how you might use this GIS technique. That's all for this lecture. Thanks.